Okay, so let's look at this one now. Area of a square is increasing, so, and the area is equal to 16 centimeters. So area is equal to side squared. So when area is equal to side squared, and I wouldn't use length times width. So I said something in class about this. I would not use length times width because it is a square. So what I'm looking at is taking the derivative of area, 2s ds dt. And then what you realize is I have the rate of change of the side, so this is ds dt, but I don't have what s is to figure out what the area's rate of change is. But I do know that the area is equal to 16 centimeters. And so if 16 is equal to side squared, then the side is equal to 4. I understand that when you solve these equations, you get plus or minus 4, but I cannot have negative 4 as a side length. So dA dt is equal to 2 times 4 times my rate of change, which is 6. So I get 48. And this is in centimeters per second, centimeters squared per second. Okay. Here, radius is 5. It's a cylindrical tank. Volume is 3 cubic meters per minute. So volume of a cylinder is pi r squared h. I take the derivative of, remember our steps. So I find the equation, then I take the derivative implicitly. I don't plug in until I take the derivative implicitly. So I have my pi, he'll just hang out on the outside. So I have product rule between r squared and h. So h times 2r dr dt plus r squared times 1 dh dt. Okay. So now what you realize is you're going to start plugging stuff in. What am I looking for? I'm looking for the rate of the change of the height. So I'm looking for this guy. I don't know a whole lot of stuff. I don't know what the height is. So I don't know what the height is. I know what the radius is. I don't know what the rate of change of the radius is, or at least so you think. And then, so now I'm like, okay, what am I going to do? So my dV dt is equal to pi 2 pi h r dr dt, right? So that is this first term. And then plus pi r squared dh dt. Okay. But what you notice is, if you think about this for a second, the cylinder's radius is not changing. So that dr dt is 0. So really, I have dV dt. So I didn't actually need h. Pi r squared dh dt. And I know what the rate of change of the volume is. That's 3 pi. My radius is 5. And then dh dt. So then I get my dh dt is equal to 3 over 25 pi. And this is in meters per minute. I'm going to skip this one because we did one very similar to this in class. So if you're confused about this one, take a look at the live stream. Okay. I do want to briefly talk a little bit about 7. So notice this is a standard free response type question. So a ladder is leaning against the wall, base of the ladder is being pulled away. What you're doing is you're relating side lengths together. And you relate side lengths together by Pythagorean Theorem. So this is a squared plus b squared is equal to c squared. So again, 2a dA dt plus 2b dB dt is equal to 2c dc dt. Okay. And what do I know? I know that how fast base is 7 feet. So this is 7 feet. I know that the ladder is 25. So then 7 squared plus b squared is equal to 25 squared. So 49 plus b squared is equal to 625. So b squared is equal to somebody. 576. So then b is equal to 24. Okay, so what do I know? I know that the ladder's rate of change, the length of the ladder is not changing. So dc dt, that represents the rate of the change of the length of the ladder. This guy is a big 0. So this whole term cancels out. So I have 2a dA dt plus 2b dB dt is equal to 0. So my a is 7, so 2 times 7. The base of the ladder is being pulled away at a rate of 2 feet per second. So that's 2 plus 2 times 24 times dB dt, which is what we're trying to solve for, is equal to 0. So this gives me 28 is plus 48 dB dt is equal to 0. Okay, so 48 dB dt is equal to negative 28. Divide by both sides by 48, and you get dB dt is equal to negative 28 over 48, which is negative 7 over 12. And this is in feet per second. Okay. Makes sense to make it negative because how fast is the top of the ladder moving down the wall? So the distance between the top of the ladder and the floor or the ground is getting smaller. So because that distance is getting smaller, then your rate of change should be negative. This one is area. So I would have done area is equal to 1/2 AB, and then you're going to take the derivative implicitly. So dA dt is equal to 1/2 B times dA dt plus A times dB dt, and then I'm just going to plug stuff in. Plug in what you know. The only weird one here will be tangent. So the angle between the ladder and the wall, which is that top ladder, or that top angle, sorry. And so we're going to use tangent of theta. All the physicists in the world use tangent of theta, so we'll use tangent of theta is equal to opposite over adjacent. Again, step 1, find an equation. Step 2, take the derivative. Step 2 is not plugging stuff in, so don't start plugging stuff in. So secant squared theta d theta dt is equal to b times dA dt minus a times dB dt all over b squared. And what you're solving for is d theta dt. So you're going to be like, oh no, what am I going to do about this guy? My secant squared of theta. Remember, this was 7, this was 24, and this was 25. If I wanted to find secant of theta is hypotenuse over adjacent, so that is 25 over 24. So when I want secant squared of theta, that's going to be 25 over 24, the quantity squared. So now you can take this and plug it in there, and then plug in everything else, and you should be okay. Okay. I said that she didn't have to do the extra 7A, 7B, so we'll finish that, and that's it.